Hello dear student, welcome you in this physics video, and in today's video student I am going to solve some of the numerical which is based on this block and tackle system. Okay, so generally we are known with this one. Okay, for a block and tackle system this mechanical advantage is greater than 1. Okay, so here I'm going to take this very first question student, that draw two different set. So what is over here, with the help of this colored sketch I'm going to highlight it. So here that two different set I have to show of the pulleys, each with mechanical advantage 4. Okay, so what we have to do, we have to draw the two different set of this pulley for which mechanical advantage is 4. Okay, so let us look over here student. This is that very first set that I am going to draw, as it is having mechanical advantage 4. Okay, so therefore student, it is block and tackle, because single fixed pulley, single movable pulley is having its mechanical advantage 2, and above that it is that of block and tackle system. Okay, so here it is mechanical advantage is 4. So ideal machine, if we are supposing, then there will be two these pulleys in the upper block. So here it is the two pulleys in the upper block, and there we are going to have this hanger, and two pulleys in the lower block we have to show. So one pulley is this one, and there is this second pulley, and there will be the hanger for this lower block, and here the load is attached with it. Okay, it is a load. Now how we will tackle it? So for this tackling, that we can use student, the this rope will cover the first uppermost, then the lowermost, then once again in the upper block, and it will come to this lower block second pulley, and then it will be tied with the this hanger of the upper block. Okay, so effort is going to be applied at this end, and tension which is developed, it will be over here, T T T. Okay, now over here, how many that tension is going to lift it up? So we are having 1 2 3 4. So 4 tension, they lift up only this load. Okay, and this tension, it is against of this effort. Okay, this is the one of the set. And while I have given the elaboration of the topic, so that time I said to you student, that you have to prefer only that combination in which either upper block is having the same pulleys as in lower block, or either that it will have a greater pulley. Okay, but here they said that two different set of same mechanical advantage. Okay, so therefore here in the lower block, now I'm going to add more pulleys, but it is not efficient. Okay, because that it is not convenient to apply the force. So let us to see in this case student, here it is this is the one pulley, and thereafter it is over here, with the help of this hanger we are going to hang it, and it is the upper block, and thereafter we will have this lower block. So in lower block student, we will keep over here two pulleys. Here it is two pulleys. Okay, so load will be attached with the lower one. Here it is the load with this one. Okay, and this is the hanger over here. Okay, so in this case student, we have to that tackle it from here. The lowermost will be covered first, and then it will go to this upper block pulley, and when it will cover it, so then it will come to this lower block again, and after covering this pulley, and this will be attached with the hanger of upper fixed pulley. Okay, so in this way, so at this edge we are going to apply the effort, and that tension student, now the tension will be over here in the upward. So always to show the tension in every part of the segment, it is in upward direction, it is T. Okay, so now look up over here, how many tension is going to lift this load up. So then again you will find that this tension is also in upward, which is going to lift the load. So 1 2 3 4. Okay, so this mechanical advantage is of 4. Okay, thus we are having these are the two set, but as it is said to you, this is not the convenient method of using this block and tackle system. Okay, so we prefer only this left side because here easy to apply this effort. Okay, so this is now let us to look for the next question. Okay, so in this second question, student, what is said to us? So we have to work according to the situation. So the question is, a machine is operated by an effort. Okay, so there is effort of 80 Newton. I'm going to highlight those important point, which is the demand of the question. So acting downward and moving through downward displacement. Okay, so they are having the downward displacement of this effort, and this downward displacement is of that 0.15 meter. Okay, and there this load is given of 10 kilogram. Okay, so it gets raised up by 10 centimeter. Then we have to find mechanical advantage, velocity ratio, input output. Okay, so all that we have to calculate in this question, and this g value we need to use it is as 10 meter per second ka square. Okay, so first student, let us to see that what thing is given over here. So solution that we will start. So effort is given to us in this question. Effort is of 80 Newton. Okay, and the next thing which is given to us that this effort it is in downward and it displays by this 0.15. So displacement of effort is said to us, which is of 0.15 meter. Okay, and next is that one, this there is the load. Okay, so load is given to us, so which is of 10 kilogram. But student, as we are known with this thing that this load it is going to be force, and force is given in Newton. So therefore if mass is given, so we will multiply it with g, then it will become weight. Okay, so weight is measured in Newton. So mass is of this load is 10 kilogram, and when I will multiply it with 10, because they said that g value is 10, so then it gets changed into this Newton. Okay, so load is of 100 Newton. And one more thing that they said, it gets raised up by, so how much is the displacement of this load? It is by 10 centimeter. So you will find that this one it is in standard unit, but it is in CGS, so we need to convert into the same standard of the unit. So it is of 0.1 meter that we will have. It is 0.1 meter. Conversion we did as 1 centimeter is equal to that of 10 to the power minus of 2 meter. Okay, so on the behalf of this we have done this conversion. Okay, now let us to look over here. That is what we have taken. It is the given which is in the question. Now our demand is to find out this mechanical advantage. So mechanical advantage, student, first thing I am going to calculate. It is given by load to that effort. How much is load? Load is of 100 Newton, and this effort is of 80, and thus I will get over here when all these things will cancel, so it is that of 1.25. This is the mechanical advantage. Okay, now the second thing, velocity ratio. So velocity ratio is what? Displacement of effort to the displacement of load. How much is the displacement of effort? It is 0.15. And how much is of that load? It is of 0.1. Okay, so over there, if you will remove the decimal of this, so what will happen? 100 will come in the divide, and if decimal of this 1 will removed, so 10 will go up. So there it is 1.5. So velocity ratio is of 1.5. Now the third thing, which is our demand over here, how much is the input work? Okay, input work. So input work is what? So that it is work done by that effort. So it is force into displacement. So work done by effort, it is said to be input, and it is force into displacement. So force is effort, and displacement is that displacement of effort arm. Okay, so thus we are having effort is given in this question, which is of 80, and displacement is of this effort arm is 0.15, and when we will multiply, so that will come out to be 12. So it is joule, because this is work done. And the fourth part of the question, it is work output. So it is work done on the load by the machine. So it is given by L into TL. Okay, so which is further equal to how much is that load? It is of 100 Newton into that of 0.1, and which is equal to that of 10 joule. Okay, this is that I am having. Now the fifth point is that, fifth point is what? We have to find out efficiency. So efficiency is what, student? We already known that it is given by a ratio of output work to that input work. Okay, you can also calculate it with the help of this formula, which is mechanical advantage to that velocity ratio, and with the help of this you can do the same. Okay, so work output is how much? It is of 10 and upon my 12, so that will come out to be this 0.833. There is this one, or percentage if we want to calculate, so that will be equal to multiply it with 100 and we will get 83.3%. This is percent now. Okay, you can also calculate that one with the help of this formula, mechanical advantage to that velocity ratio. Okay, so over there mechanical advantage is what? 1.25 upon may that of this one is there, velocity ratio 1.5. Okay, so you will get the same way that answer. Now let us to look for this question number 3. So in this question number 3, student, it is said to us that mechanical advantage of a machine is 5 and its efficiency is 80%. So it is used to lift a load. So load is of 200 kilogram force, and we have to find out effort and this velocity ratio. Okay, so our demand is to find out over here effort and this velocity ratio. So first thing that it is regarding what is given to us. So mechanical advantage is given to us, which is equal to 5, and the second thing is given to us, which is efficiency. Efficiency is of 80%, or you can say that it is 80 by 100, and this is 8 by 10 or either 0.8. Okay, so this is what 0.8, you can mention this one. So this is efficiency over here. Okay, so they are asking us that how much is the effort. So if there is load of, so load is given to us, which is of 200 kilogram force. Okay, this is that load, and we need to find out over here effort. Okay, what is the effort and what is the velocity ratio? This is our demand. Okay, so for this question, student, that how we can calculate this velocity ratio? Mechanical advantage given to us, efficiency given to us. So here first part you can do that. Efficiency is what? Mechanical advantage to that velocity ratio. Okay, I'm not taking over here a percentage. It is simple efficiency. Okay, without percentage. So velocity ratio, that will be mechanical advantage to that efficiency, and which is mechanical advantage how much? It is 5 upon my that of 0.8. So if decimal will be removed, then it will be 50 by 8, and which in turn is equal to that of 6.25. Okay, so this is what? This is that velocity ratio. Now the next thing is there, that how much is the effort? So student, as we are known the formula of mechanical advantage, because mechanical advantage given to us, so it is load to the effort. Load is also given, so our demand is to determine only effort. So it will become then, take the effort to the left and mechanical advantage to the right side, so it will go in the denominator. Okay, thus I will have, it is over 200, so it is kilogram force, remember that unit is there, upon may 5. So when it will cancel, so there it will be 40 kilogram force. Okay, so in this way that we can solve this question. Again you can check that one. Now there is this question number 4. So here student, what we have to do in this, so we have to draw this diagram for that velocity ratio 3 comma 5. Okay, so we are having this block and tackle system. So in it that this pulley system will have its mechanical advantage. Sorry, velocity ratio is 3 and velocity ratio 5. So that diagram we have to show, and we have to indicate the direction of the forces. Indicate the direction of forces, and what will be the mechanical advantage. Okay, so first the thing we must to share over here that it is the case of block and tackle system. How is this one block and tackle system? So remember that this velocity ratio is 2 for which it is for single movable pulley. Okay, it is 2 for single movable pulley, and velocity ratio is 1 for this single fixed pulley. Single fixed. Okay, there is only single movable and single fixed. For that one, velocity ratio value is 1 and 2. But if there is more than this 2 value, that's velocity ratio will come. So that will be the block and tackle system. Okay, so let us to draw over here this velocity ratio of 3 and velocity ratio of 5. These two block and tackle system, student. So here there is this rigid support, there is this frame. 3 they are saying. So velocity ratio generally it is number of pulleys. You can take that one as in short. Okay, so how many pulleys we have to use? 3. So that means upper block will have more pulley as compared to the lower block. So 2 pulleys in the upper block, then I will use. Here it is, and this is the hanger, and in the lower there will be the single that pulley in the lower, and here it is, the load will be attached. Okay, now we have to cover it. So for covering, uppermost will be covered first, thereafter the lower block pulley will be covered once again in the upper block, and finally it is going to tie with the lower hanger of this lower block. Okay, so that tension developed, it is given in upward. Here it is the tension developed. Okay, and this effort is applied at this end. Okay, so this is velocity ratio equal to 3. Okay, if all the thing is weightless, means pulley is weightless, this string is weightless, so mechanical advantage is equal to that number of pulleys. Okay, or either it is what number of that segment, or either it is said to be strands holding the rope. Okay, so that it is also equal to 3. Okay, so when we are going to take it as 3, because for weightless machine part, okay, so this mechanical advantage and velocity ratio will remain same. Now for this velocity ratio 5, then student we will have this one as, here it is rigid support. This is the that frame, fixed frame. So in it that I have to use one of the pulley. Just to check that velocity ratio is 5, how many pulley I have to use? It is 5. So it means 3 in the upper block and 2 in the lower block. Okay, so already it is said that in upper block you must have greater, if there is the need, then greater in the upper block as compared to the lower. So then I'm going to use 3 in the upper block and 2 in the lower block. But remember, there must be a spacing between the two. Okay, don't attach them together. So this is the block, and this dot which I am showing, it is the axle. Okay, and here it is the hanger, and 2 will be in the lower block. Here is the 2, this is 1, and here this is 2, and this is as load over here. Okay, now this is the hanger. Once again, start to cover it up from the uppermost. This tackle will come to the lowermost pulley, then it will move upward. Once again covering, it comes down, and here once again after covering. Now here the finally it is going to attach with the lower one. Don't attach with the upper this hanger. Okay, so we are having, this is effort applied over here, tension is at this end, and in every segment of this rope, there is the same tension developed. So in this way that tension we need to show. Okay, so this tension, it is always in a upward direction. Okay, this is velocity ratio is 5, and if there is weightless part, then mechanical advantage student is equal to number of pulleys in this tackle block and tackle system, so that it will be also 5. Okay, so this is all from my today's video. Thank you. Keep on study.